Good day. So I'm here to talk about some aspects of Wi-Fi 7 since we are getting a lot of attention on Wi-Fi 7, especially with multi-link. I thought I'll kind of outline some terminology that we are going to see out there in all kinds of literature, even before products become, let's say, prevalent. We're going to see all this terminology and people are going to bombard us with all these things. So I thought maybe I can share some insights about what they are and how they become useful for you when you read a document or look at something on Wi-Fi 7. My name is Srikanth and I'm with NanoCell Networks. Quick introduction to multi-link. By the way, multi-link is also going to be known as MLO. So that's the first terminology. If you hear MLO, then that's multi-link operations. Multi-link allows an AP and a client to interact on multiple links, either by steering or load balancing across those links, or aggregating. The first terminology, which is slightly deeper than MLO, is this concept that now our AP, if you see in some brochure that it's an AP MLD, then don't be worried, it's an AP multi-link device. And similarly, as I said, the multi-link is not only restricted to steering across the links. It might be also used for, say, aggregation use cases, where an AP and a client might aggregate multiple links. These are just examples where I'm showing 2.4, 5, and 6. There could be multiple links operational on 6, multiple links operation on 5. Hopefully, there will not be multiple links operational on 2.4. Okay? So while we have the AP MLD, we also have the non-AP MLD, shown maybe not so clearly at the bottom of the screen here. So that's the station side description, where you have a multi-link device on both sides of the connection, AP side, AP MLD, station side, non-AP MLD. Multi-link or MLO is going to be mandatory for Wi-Fi 7. So practically speaking, all access points and client devices are going to be certified, and many of them will not be certified, but still supporting many of the features will support MLO, and so you will see the word MLD used in this context. So that's the very first, you can say, terminology you're likely to encounter in the Wi-Fi 7 world. The next terminology which I think you might encounter, especially maybe slightly into the technical side, is this word called upper MAC. Most of us in the Wi-Fi area have heard about MAC and PHY, but now, because of multi-link operations, the IEEE has defined a logical sublayer in MAC called upper MAC, or UMAC is the term that you will hear. And UMAC and LMAC are going to be used quite often in some of the technical descriptions. 802.11 standards have defined clearly what this UMAC sublayer will do, what this LMAC sublayer will do, and so things like association and security will be taken care by UMAC. LMAC will take care of more traditional MAC functions that we already know, which is all the aggregation, carrier sensing, etc. Okay? So if you hear UMAC and LMAC, you know what they are roughly doing, and you know that they are connected to the MLO side of things in Wi-Fi 7. What's the next one? So MAC addresses, again, anybody working in the 802.11 Wi-Fi space, we're already familiar with all the MAC addresses going on in the air. We now have a new term there called MLD MAC address. This is the MAC address which is going to be handled at UMAC, which I just introduced. And that will basically kind of be the binding MAC address at the multi-link level between the AP and the client. In fact, I should strictly say it'll be between the AP MLD and the non-AP MLD. Okay? So both AP side as well as station sides can have multiple MAC addresses, and the binding address at the multi-link level is going to be the MLD MAC address, as we call it. They will not have different bit sizes or anything as compared to our wireless MACs that we have seen on the frames going on in the air, but there's just new terminology, and their use will be for many purposes, like in calculation of certain security keys and so on. Now comes to the language which you are likely to see more often. For example, client side, will have a lot of different, you can say, types being advertised. One of them, which is going to be popular, is called MLSR, Multi-Link Single Radio. Basically, client sides are constrained by a lot of, you can say, power, cost, and so on. So they will want to use multi-link without having to pay a lot in complexity. So they might just want to be able to switch across links. So that kind of a device is going to be quite popular on the client side, called as multi-link single radio. And as I've said here, multi-link does not imply that all the devices will support multiple radios. In fact, the devices which support multiple radios, they're going to be referred to by another terminology that you will encounter called MLMR, multi-link multi-radio. Access points, especially the types that we usually use in enterprises and homes, etc., those will be by default supporting multi-link multi-radio. In fact, they do even now, except that they don't support standardized multi-link operation. Client sites are the ones which are going to be constrained, and so some high-end clients might do multi-link multi-radio, and some subset of those clients might also support what we call STR. So this is another terminology that you will encounter in Wi-Fi 7. So this is simultaneous transmit and receive. So STR implies that a client could receive on a link while simultaneously being able to transmit on another. Okay? So this is going to involve a little bit more complexity on the client side. Remember, I said APs by default will support them. Clients are the one which is going to have to support them only if they feel that, their market demands it. So some high-end clients, you might expect to support this feature. Many clients might also support what is called as an enhanced multi-link single radio, or what is called as EMLSR. So this is again something you will encounter, EMLSR, where a client, and the most popular client from a data perspective is 2x2, can listen simultaneously on 1x1 radios for certain frames and then quickly change the links to have full 2x2 MIMO powers based on channel availability. So many client vendors think this gives them sort of the best of both worlds, not having to implement multiple radios, at the same time taking benefits of multi-link. So expect to see a lot of EMLSR terminology. Of course, access points have to support signaling to clients so that the clients can switch over those links according to the availability. Then we have some things which we're not going to see as much in products, but just to know, if you're thrown with this name, a non-simultaneous transmit and receive, they can still do multi-link. TX, not so synchronized at all times, start and end. And here, start and end both synchronized. This is only possible on downlink. This has to be there for uplink. This is synchronous access. It requires a lot of work, and ergo, we don't think that we'll have a lot of products supporting that. But IEEE standards have specified operation of NSTR. So if you come across this language, you know what it means roughly. And finally, in this category, we have this EMLMR. This is multi-radio, multi-link, but you can dynamically change the number of chains to each links. So you might shift from a 2x2 to a 3x3 on one of the links, and then maybe take off something from another. So it's a dynamic change of transmit and receive chains on the links. Again, we don't expect this to be too popular, but if you hear EMLMR, you know what this is roughly. And just to summarize, this is a nice table in one of the IEEE documents where they've looked at MLSR. As I said, this is the low-end client, just one radio, one link operation at a time. EMLSR uses the same number of radios with some extra complexity, and you get the benefits of multi-link as shown in a lot of data in IEEE documents. So this is something that many clients are favoring. Some low-end clients might go to this. As I said, NSTR, unlikely to be that popular. STR is going to be the high-end client. Remember, APs will default support that, and you will need more than 2 radios for this. And this is more of a very futuristic device. We might not see so much of that in practice, but it's out there in the IEEE spec. Are there any more? So just a few more things. Multi-link probing is something that you will see in Wi-Fi 7. So it's not a special type, but it has some different elements. So multi-link probing on the request side and the response side are some terminology that you are likely to encounter. So if you hear ML probe request, ML probe response, you know that ML probe request is eliciting more information about multi-link, and ML probe response is sharing that information from the AP side. And finally, to tie it all, if you ever hear multi-link element, then you know that that's the one which is going to share all information about multi-link, sometimes light information, sometimes detailed information, and there's a lot of flexibility that IEEE has allowed in frames like, you can say beacons, probe responses, and then the multi-link probe responses, okay? So I think these are the few terminologies I think which you might encounter when reading technical documents, white papers, listening to presentations from vendors over the next couple of years as we go through the Wi-Fi 7 evolution. And I hope this is useful for you to keep track of what they are. So if you ever need more information, please take a look at our website. We also offer courses through Wi-Fi Now Academy, and I hope you can join one of them. Thank you, and look forward to seeing you soon. Bye-bye.